Welcome to the unit circle. In our textbook, this is 13.4. Our objectives are to convert angle measures from degrees to radians or from radians to degrees, and also to find the values of the trigonometric functions on a unit circle. Our vocabulary for this section of the unit includes the following two words, radian and unit circle. And as we get going into this, we've mostly been measuring our angles in degrees. We're now going to look at angles measured in radians. When we're looking at angles measured in radians, we have this basic definition of a radian, which is a unit of angle measured based on the arc length. When we think back to our geometry, an arc is an unbroken part of a circle. If we have a central angle theta in the circle with a radius of r, then the measure of theta is defined as 1 radian. When we think about our circle, we know from older geometry classes that the circumference of a circle with the radius equal to r is equal to the formula 2 pi r. If we go only halfway around the circle, we have just a single pi. If we go all the way around the circle, if you're looking at the diagram on the right, 360 degrees is equal to 2 pi radians. So what we're establishing here is our conversion factor. When we're looking at 180 degrees, that's equal to pi radians. 360 is 2 pi radians. So when we take an angle representing one complete clockwise rotation, we have the 2 pi radians. We can use that when we're converting between degrees and radians. These two parts of this table show you going from one form of measurement to the other. So from degrees to radians, we're going to multiply the number of degrees by pi radians over 180. If we have been given radians, we'll multiply by 180 divided by pi. Now, instead of memorizing this particular table, if you use the strategy of dimensional analysis to start canceling out your units, you'll keep it pretty much straight as you're doing them. So if we're going to convert each measure here from degrees to radians or radians to degrees, and we've got one of each, we're going to start with negative 60 degrees. Our information tells us to multiply by pi radians over 180, which would look like this. If you think about dimensional analysis, and we set this up, you can see that we have formed this grid, if you will, where our degrees are going to cancel out right here. And in this section on this side, we have our conversion that we're going to use. So when the degrees cancel out, our remaining unit is the radians. And you'll notice that we keep the pi radians, and we're not going to multiply by a value of pi. We're going to keep that value of pi there since that is a non-repeating decimal. We're never going to really change that. So we're going to keep that as an exact answer. When we look at the other one, we can see that instead of multiplying by pi radians over 180, we're doing the reciprocal. And so you might notice as we set up dimensional analysis here and set up that grid, if you will, that this radian stays on the top. Okay. That actually, sorry, 2 pi over 3, we're just going to leave it the way it was. So 2 pi radians over 3, we're going to cancel out the pi radians here and the pi radians here. Multiplying 2 times 180 gives us 360, divided by 3 gives us our final answer of 120 degrees. And if you have taken that process before, whether it be in chemistry or bio or science or anything like that, you'll use it later on in physics. Using a dimensional analysis approach is a really easy way which allows you to take a conversion factor and use it appropriately and not have to know whether you're multiplying by this or multiplying by that. So let's go practice a couple. One thing to note beforehand, angles are measured in radians. Often don't have a unit. They may not say the word radians. We'll just leave it without the word radians in there, you can assume that if you don't have a degree symbol, that you are measuring it in radians. Okay, here's a chance for you to practice converting from degrees to radians or radians to degrees. Please pause the video, resume when you're ready to check your answer. Okay, for 80 degrees, we're starting with degrees. Our conversion factor is 180 degrees is pi radians. They're going to indicate to multiply by this, but we can use our dimensional analysis. The degrees cancel out if you keep them in opposite corners, if you will, of this table. And we end up with 4 pi radians. The next one then is radians to degrees. And again, a dimensional analysis approach. Keep that in the numerator section, cancel out the radians and pi, and that gives us 2 times 180 divided by 9, or 40 degrees. Our unit circle is depicted here, and I've noticed as I've strolled around the room that many of us have started to put this together in class. When we get into class next time, we are going to complete a unit circle on a larger piece of paper and discuss some of the ways that we might help ourselves remember what they are. Through the course of the rest of this year and the end of this unit, you will have an opportunity to do this from memory, so you should be working towards memorizing our values that we first looked at when we talked about our special right triangles last class. This is our unit circle. It's based on a circle with a radius of 1 unit, or we call that the unit circle, so the radius is equal to 1. For every single point where the point is a coordinate x and y on this unit circle, we can figure out our angles, and if our angles are in standard position, each of the values that we've talked about previously. That being that our sine of theta is equal to the y coordinate over the radius, or 1, so that sine theta equals y. Our cosine theta is x over r, or x over 1 if r is equal to 1, therefore cosine theta is x, and tangent is still our y over x ratio. That means, based on that information, that the point P can be written as coordinates in this manner, that cosine theta and sine theta fall into place in their x and their y positions. So this diagram gives us the equivalence of degrees and radian measures and their associated or corresponding x and y coordinates. What you'll notice from each of these coordinates is that they are the values that we've started memorizing and recognizing from the table from our last class. Again, we will develop our unit circle in class in such a way that you will have a easy way, hopefully, to memorize where they are all located. We're going to take that unit circle, and you can open your study guide if you've already completed your unit circle, and find the exact values of each of the trigonometric functions. Given that we have cosine of 225 degrees, our first step is to figure out where 225 degrees pass, and it happens to pass through the point that's negative root 2 over 2 for our x, or our cosine, and our sine is negative root 2 over 2 as well for the y on the unit circle. We take cosine 225 degrees equals x. We're going to use cosine theta equals x, and what we're looking for is the x value within that coordinate. On the other hand, we can try the same scenario, this time with our radian measures. We're looking for the tangent of 5 pi over 6, and this specific angle is found in the second quadrant. It helps to look at your unit circle when you see this. You will notice that associated with 5 pi over 6, the point is negative root 3 over 2 and 1/2 on the unit circle. And we want the tangent, and we remember our tangent is the ratio of y over x. Since y is 1/2 and x is negative root 3 over 2, we place them in their appropriate spots and then solve. We end up getting the tangent of 5 pi over 6 being equal to negative root 3 over 3. It's your opportunity now to take and practice. Look at your unit circle, find the exact value of sine 315 degrees, pause the video, and resume when you're ready to check your work. Okay, sine 315 degrees, if you look at your circle, passes through the point root 2 over 2 and negative root 2 over 2. This is in our fourth quadrant, and it really helps if you're not looking at your circle to draw a picture of the unit circle and where 315 degrees is. Our y coordinate of this point is the value of sine, so we're looking for the y coordinate, and we end up with negative root 2 over 2. Next, try this with 180 degrees for tangent. Find the exact value, pause the video, and resume when you're ready to check your work. Okay, our tangent 180 degrees passes through the point negative 1, 0. It's along the x-axis on the far left-hand side. When we consider that we have our x-coordinate is negative 1 and our y-coordinate is 0, and place them in the appropriate ratio for tangent, we end up with 0 over 1, or tangent is 0 at 180 degrees. Last one, go ahead and try the same thing again, this time with radian measure, cosine 4 pi over 3. Pause the video, resume when you're ready to check your work. Cosine 4 pi over 3 ends up in the third quadrant, so it passes through negative 1/2 and negative root 3 over 2 on the unit circle. We're looking for the cosine of this particular angle. Cosine is equal to the x value, so we end up with cosine of x over r, or x, which equals negative 1/2. We've talked last class about reference angles and the quadrants in order to figure out what our trigonometric functions are. What we're going to work on with this is understanding that all of our values can be memorized in quadrant 1, and then we can use our understanding of our signs in the other quadrants to help us in determining the values of our trigonometric functions. You can see in this table a step-by-step guide for the way that you would be able to use those reference angles and the values you memorize from quadrant 1 to do all of the values in the complete unit circle in all four quadrants, all three besides quadrant 1. Go ahead and read through this, pause the video for a second, and make any notes that you want to related to the information presented here, or take a quick picture and save it. Okay, moving on with this, I'll just remind us real quick, we had a quadrant diagram and we had an acronym to help us remember where the signs are positive. That reminder is the phrase, all students take calculus. Quadrant 1, where we have everything is positive. We have quadrant 2, only the sign and its reciprocal, cosecant, will be positive. In quadrant 3, where we get to take, the word take, that's the tangent and its reciprocal to cotangent, are positive. And then the last one, calculus, being that word comes from or associates with cosine theta, and cosine and its reciprocal secant will also be positive in quadrant 4. Using the information presented in the table and some of the steps there, we're just going to run through a quick example on how we might evaluate our trigonometric functions using the basis of knowing the quadrant 1 and then knowing how the signs change per quadrant so that we can work through this. So first, we want to find the reference angle so that we can help us determine the exact values of sine, cosine, and tangent of 330 degrees. So here's a picture. If we went in the counterclockwise direction, starting at this side right here, went all the way around, we would have 330 degrees. Now if we overlay a quadrant on top of it, this ends up being in the fourth quadrant. Our reference angle, if we were to look at dropping a line directly, we're looking for the angle that appears between the terminal side here and the x-axis here, and that would finish out as 30 degrees. So we're going to take this and put it all on a coordinate plane on the next page. Here's our coordinate plane, our reference angle of 30. We're associating our information now with quadrant 1. So everything that we do at this point is now just looking at it from the quadrant 1 point of view. So if we had 30 degrees in quadrant 1, what would we have? Sine of 30 is equal to 1/2 if you use your unit circle or if you're starting to memorize. Cosine of 30 is root 3 over 2. And then our tangent of 30 is root 3 over 3. Now what we have to take from here is we have each of our values. We now have to apply the sine or adjust the sine based on where this particular angle is actually located. Our angle is located in the 4th quadrant and our y value is negative there, so is sine. Cosine of 330 is positive in quadrant 4. And tangent, because one of the two parts of the ratio, the y is negative, this will make the tangent negative in quadrant 4. Your time to go ahead and pause the video and find the exact values of sine, cosine, and tangent of 270 degrees using a reference angle to help you complete that. Resume when you're ready to check your work. Okay, 270 degrees is down at the lower part of the coordinate plane, so it's exactly on the y-axis. We know it's facing down. The sine on that side is negative, and cosine is actually a very special case down there. When we're looking at the cosine and sine, we have sine is of 90 degrees. Now, if you remember, we're kind of considering this in quadrant 1, so we are looking at this being a 1 because we're considering quadrant 1, so it actually probably should be facing, this way. This way. 90 degrees is up this way, and this would be a value of 1. This down here is actually a value of -1, but we're going to associate and adjust the signs after we consider what each of the values are. Moving on to our cosine of 90 degrees, we're at the y-axis, so x is equal to 0, and tangent is undefined in this location because our x, or our denominator, is equal to 0. And we're going to move on to adjusting the signs, and we kind of already looked at that. Nothing really changes other than our sine of 270 degrees becomes -1. Now we can take the measure of a central angle and determine the length of the arc, or S, by that is intercepted by that angle. And this is a ratio or a proportion that is set up where we have the angle theta divided by 2 pi is equal to the arc length divided by 2 pi r. And we are going to get some grasp of understandings here. So our arc length intersected by the angle by theta, and the arc length intercepted by the circle is our proportion on the right hand side. The radian measure of theta, the radian measure of the circle completely all the way around is 2 pi. When we go ahead and solve or simplify, we end up determining that the angle theta, or the radian measure of it, is equal to the arc length divided by the radius, or r. And we can then further simplify that because we want to find out what the angle or the arc length is. S is the arc length. We want to figure out that our arc length is equal to the length of the radius multiplied by the radian measure of theta. We're going to go through an example that's actually a little bit more difficult than you will see, but it is important that you memorize or remember this formula. S, the length S of the arc, is equal to r times theta. And that's the formula that you'll want to make sure that you commit to memory. We'll have very simple problems that are related to that, different than what you're going to see next. Okay, here's an example of how we might apply this. We have a tire on a car. That particular tire makes 653 complete rotations in a minute. When we look at the diameter of the tire, it's 0.65 meters. So to the nearest meter, we're going to figure out how far the car travels in 1 second. First step is to find the radius of the tire, and we know the connection between radius and diameter is pretty specific, and so we're going to divide by 2 to determine that r is equal to 0.325 meters. Next, we're going to take the angle theta through which the tire rotates in a second. And we have to convert that. We have 653 complete rotations in a circular pattern, means that we have, in words, our radians rotated in 1 second over 1 second is equal to our radians rotated in 60 seconds over a second. And that sounds funny, so look at the next page because this is what it works out to be. Our angle theta in radians over a second is equal to 653 rotations times 2 pi, which is the amount of a single rotation. So we've got 653 2 pi's. And we're going to divide that by 60 seconds. And that's basically what they were asking for in a minute. We end up with our simplified form of 653 pi over 30. And moving on to the next page, we're then going to take that angle theta and put it into our formula to figure out the length of the arc. Our first step is to understand the formula, then substitute the values. Radius, or r, we figured out was 0.325, and then our theta is 653 pi over 30, and we end up simplifying to be 22 meters in a second is what the car travels. That completes our video for the unit circle. Take a few minutes, go over your study guide, review anything that you need to. Make sure you make note of any questions you'd like to ask in class next period.